Mariota project as well. And Alex has been invited specially to a meeting on the June the 12th by our local chief minister, who is meeting at the satellite company, because the satellite company are also helping to launch not just their own satellites, but also their own state satellite. So there will be a South Australian state satellite going up as well. And he's very interested in the connection of the satellite to education. In the past, it's been too difficult to do development, very difficult even for a development industrial company to actually develop this into a product and use it. Too difficult for university students, and of course, not possible really for high school students in the past. But because we have connected this to this easy coding technology, which you'll be learning today, then suddenly there is access to this. You see the cable then actually can connect through, and you can then communicate with this to send the signal to the satellite, so you can do real projects in STEM to send to the satellites, even for students in high school and even upper primary school to get started. So this is really a world first. We know because we've been doing a survey, and we want to continue the survey here at UOW as well. Okay, UOW survey. So if I can get maybe Dr. Sompon, you can do another recording for me. What we're going to do is edit these recordings together, and maybe I'll get Alex to help do some editing afterwards when we get back. And we are going to show a show of hands. So today I'm going to be interactive. So everyone just put their hand up. I want to see if you can put your hand up now. Everyone just raise their hand. Raise their hand. Yep. This is not a question. This is just an exercise to see how high you can raise your hand. Okay. Don't raise your hand like this. It has to be above your head, right over here. Reach for the ceiling. That's better. That's better. I don't want to see any shy hands. Okay. There's no shy hands. Good. Good. Okay. Put your hands down. The reason you need to raise your hands is if I ask a question, then you can raise for yes or no. But secondly, if during the workshop we have any problems, then I want you to raise your hand quickly so that we can sort it out, and then everybody can continue as well. Don't just wait. Don't think, oh, maybe I'm doing something wrong. No embarrassment. I have Dr. Sompon, I have Alex, I have ETO. ETO also, stand up, ET. Put you on the camera. Okay, so ET is here at University of Wollongong. He is actually also a lecturer here. So he has done these workshops before, both with me and without me, and he can also help as well. So thank you very much, ET, also for joining us. Okay, thank you. Okay, very good. So I'm going to do a survey now. Okay, I'm going to do a survey now, and the survey question is, okay, the survey question, listen very carefully. Okay, so we've done this survey before, and the question is that if you have never heard of using satellites for STEM, for education, if you have never done a project before, okay, then, and if this sounds like it is a world first that you've never seen before, then I want you to raise your hand. So in the past, everyone has raised their hand from our survey before. Raise your hand up nice and high. Okay, very good. And we can show the minister that this is a world first. That's why we're showing this, that in every place we're going, it is actually a world first. Thank you. Everybody has raised their hand. So nobody, I think, has done the project before. Okay. All right. Good. Good.
Someone raised their hand on the Google meeting.
Sorry?
Someone raised their hand on the Google meeting.
Oh, okay. All right. So they have never heard of it before as well. Okay. So all of those on the Google Meet actually participated in the workshop as well. Okay. Very good. Who was that? Was that Latoya? Maybe? Okay.
No.
Was that you, Latoya?
No.
No. Okay. All right. Sorry, while we're talking to Latoya, and maybe Latoya, you can quickly say hello and where you are and how you've been connected to stem cell just for a minute.
Hi, everyone. I'm Latoya Samuels Wharton. I am located in Philadelphia, Pennsylvania. It's almost 11 p.m. here, so it's my bedtime, actually. I am connected to stem cell through, I'm a consultant here in the U.S., and I provide STEM services to young people. So I rely heavily on stem cells, unique innovations and technology to present to young people.
Okay, thank you, Latoya.
You're welcome.
Yeah, I don't think we heard maybe the first part. So did you say you're in Philadelphia?
I am in Philadelphia, Pennsylvania, and I provide services in Ghana, Cote d'Ivoire, Namibia, and also obviously Philadelphia.
International services, very good. Okay, thank you for joining today. Very good. We might have some other international visitors as time passes because, of course, there's different time zones as well. So thank you for joining everyone that's also on the Google Meet, and we'll continue then the workshop. All right, very good. We're going to do some hands-on, and I'll endeavour to get as much video as I can also to those on the Google Meet that I can. All right. So I believe that everybody has one of these kits on their table at the moment. Yes. What we want to do is actually plug it in using the USB cable into power so that you get a red dot on your kit. Okay. Let me just have a quick look as to the logistics of your cable and see whether they might be long enough or too short. Let me check that first. Everyone has a laptop. You're connecting it to the computer. Is there a USB plug? Yeah, underneath. Okay, let me get you another cable. I'll get a line. I'll get a longer cable for you. Okay, so longer cable for you, so that be able to connect that underneath, still have that on the table. Thank you. Oh, is it long run? Yes. Apple has a different USB port. Apple Apple has a USB-C, so you need to have an adapter. Let me get an adapter. I've got one, man. All right. Yeah, I have an adapter too. Oh, yeah. I have a small one. Okay. I believe everyone has their kit open. Is that right? We have a red dot on the top. Now, what I want you to do is open your. Okay, what you need to do next is connect into the runlinc network. Runlinc. So go to your Wi-Fi, and we want you to connect into a network, not this one, but the one that is called runlinc. There should be a runlinc. Okay. Let me put it up here on the board. So it's called runlinc. Run, LINC. Okay, that's the Wi-Fi. And the password is runlinc 1, 2, 3, 4. You need to connect to this because this is the same network that your controller is connected to, and it is Wi-Fi device, so that your controller can also be connected through, and you can communicate with your controller to the laptop.
Yeah, I tried
Okay.
to do this.
Oh, thank you.
Yeah, better.
Okay, Dr. Sompon is assisting with the camera. Thank you very much, Dr. Sompon. You've been very much a good cameraman on the trip. Dr. Sompon has been very good at processing images. I noticed he does a lot of coding as well in mathematics for his weather stations and 3D graphics. Okay, open your browser, your Chrome browser. Connect to this first. Is everyone connected to runlinc? Runlinc?
Apple or MacBook internet problem.
Okay. Okay, you're connected to runlinc. Yeah. It will say no internet. This is actually correct. There is no internet on this network. We do not need internet. Okay.
He can also
The
use the
Apple
PC.
AI is so clever that if there's no internet, it tries to do a diagnostic on the thing, even though it's actually okay. All right. Tell your AI that it's okay. It needs to come down. All right. Wow. We'll try to overcome the AI's. Yeah. Sometimes there's a problem when the AI gets upset, so we need to try to calm it down sometimes. All right. ET is assisting with that one to get that going. Just get onto the network on Apple. For the rest of us, what we're going to do is go to open the Chrome browser, and we'll need to, on the top line here, enter an IP address so that we can open the web page, which is inside the chip. So we do not need internet because inside each chip there is a special development website page, like a window to the chip. So type in these IP numbers, 192.168.0, and then in my case, on my yellow sticker here, I have the number 82, but you're not going to use that. You're going to use your own number on your sticker, and then the slash and control .html. Okay, and then it should open the runlinc like this. So 192.168.0, and then your chip number 82 / control .html. It should open like this. Quickly see, do we have it open? Yes, yes. So 168. 8. adoption of zero. Control, Control C. Control. Are you actually dyslexic a little bit, like the letters reading? No? Yes. Okay, connected. That one. Need some help, maybe Alex. Okay, all right, good. Check it. Yes. Okay. Yes. So copy this onto a new tab. Otherwise, we've got that's feedback. Feedback on the market.
Possible if you, is it possible if you share your screen also? You share your screen on that, and then they give the people that
Oh,
they
okay. Yeah.
they can see.
Someone has suggested that I also share my screen also on the Google Meet, which I'll do. Okay, here's the share.
Would be better, right? I think they can see.
Okay, good. So this is our running page we have open. We have a few hands. No internet is great. Don't worry about no internet. No internet is great. Okay, you don't need internet because it's the local Wi-Fi network to the chip. I mean to the chip. Okay, good. So we will check. We're going to check the connection now to your chip. So go to D2. You see the numbers here. They are actually the connection numbers. There are many connections on your chip. Before I continue, who has done some Arduino, Raspberry Pi, or has been done some coding on some chips before? Anyone? One person? Okay. Has anyone done any coding like, thank you. Anyone done any coding like Scratch or something, other type of coding? No? Yes? Okay. So most of you, this is the first time. That's okay. This is actually easy coding, so you can follow easily. These numbers here are the numbers for the connections. These numbers, this configuration is how we want to use the connection. Then we're going to use the name, and we can check the status. So there is one connection at the top which has connected to a blue LED on the controller. So select digital out, and you should see a red off button in the status. So it has a signal, but it's off. So you can click the connection, click the off connection, and you should see the blue LED on your board turn on. Okay. If you do not see the blue LED on your board turn on, then maybe you are connecting to the wrong board or something is amiss. Anybody not connected? Okay, very good. E.T. was able to get it went on an Apple. Is that Mac? Yeah, Mac. Okay, good. Very good. Thank you, E.T. So open the page, go to D2, digital out, and then try that. We're going to now, this is an output, so we can control things on and off, LEDs, we'll be plugging in other things, buzzers, we can control lamps using relay switches, fans, pumps, motors, motors on robots. Let's give this not just a label, this is actually will become a variable. Like in mathematics, you have x equals 10, y equals 20. This becomes a variable for your coding. So suddenly this blue we can use in the coding. We're going to use that in the coding to control the blue LED on and off to show you how this works easily. So we're going down to the coding box, JavaScript loop. And I can make this bigger. One of the advantages of a browser is you can use the zoom. So we can easily just zoom in. Okay. What we're going to do with the blue LED, just to show you the coding steps, is we'll make it flash, on off, flash. So what are the steps for a flash? Some of you may have done a coding before. Okay, we need to turn it on. What's next? Turn it on, turn it off. Is that it? How long will it be on? How long will it be off? Need a delay. Okay, correct. So you need to specify how long. Otherwise, on off, the microchip is faster than the blink of your eye. It'll be on off, you will not see it. So turn it on. Maybe leave it on for 1 second delay, and turn it off, and then if we turn it on straight away, off on, we cannot see it off. So we need a 1 second delay off before we start again. This is then we'll start again in the loop. It's actually called a loop. Okay, you'll repeat in the loop. So here we have a box which is called JavaScript loop. Anything we put in here will repeat using the language JavaScript. Has anyone done JavaScript before? It's used for web pages, etc. 2 of you, very good. Anything in here, this can actually take any JavaScript, but can include the IoT and AI and things from this side as well. So why are we using JavaScript? It is the native language of the browser. So for example, today we're using Windows, we're using a Mac. We don't need to go through the trouble of trying to install a driver on the Mac, your connection on the USB. We don't need to install some sort of app on the Mac or the Windows. There's no apps, just using the driver. So the browser already understands this language. Okay, it is also used by 70% of the professional programmers in the world. It is a very common language which will also help with many aspects, not just web pages, but also lots of other coding and programming. To get started, we're using macros to help to form the connections and the characters. So go to select macro. I'll show you how this works. Select the turn on. This is a special word we've added to the JavaScript. Select the blue. Put the cursor here in the corner and click add macro so that we have turn on blue. I don't know whether the feedback is coming from. I don't think it's that. Okay, then we need a delay. So select the weight, then put the cursor here and click Add Macro. Milliseconds. What's a milli? A milli. Like a millisecond is similar to a millimeter. 1,000th. Okay, if we have 1,000 of them, then we then have 1 second. So 1,000 is 1 second. Go down to the next line. We need to turn it off. Turn off the blue. Okay, and add macro. And then we will have 1 second delay again. So await, click here, add macro. Turn on, wait 1 second, turn off, wait 1 second, then it will repeat in the loop. Any questions or difficulties, raise your hand. Is everybody's okay? Then I'll continue. Everyone's okay? Good. So how do we activate this? Go to the top of the page here, near the stop code, the top of the runlinc page, and click the run code. Click run code. And you should see your blue LED flashing. Everyone is flashing. On off. Flashing. Okay. Okay, flashing attention. Yeah, good. Okay, very good. So like I said, now we can also control outputs. We can control other things as well, motors. We can control fans, we can control lamps, relays. So this is on-off output. What we are going to do now is also show you an input, how we can use a sensor to get some information, some data, and we can use this in the variable in the coding. So for example, we will use a light sensor. When we block the sensor, then the number will change. The sensor number will change. Okay, so I'm going to show you a picture of the light sensor. We're going to attach a light sensor onto the connection. So let's go to the light sensor. Okay, let me get you a picture. Go to our website, to a documents. Well, we have project folders. I'm going to use this one because it has pictures of the components we're using.
Can you show screen not only at the page of that? What you want to show all screen? Share the screen. But now show only this link to the page. Can you show all screen?
Okay. That's okay. Shared okay? Okay, right, so this is the sensor, the light sensor here. I want you to find the sensor, and you'll notice that there are 3 pins, 3 connections. Middle one here is positive power, negative power, DC like battery. okay, DC power. And this one here is S for signal. The signal voltage will change depending on the light level. When there is a lot of light, actually the signal on this sensor will go down. Okay, some sensors go up, some sensors go down. This one will go down when it has a lot of light. If it gets drops, then the signal will actually go up on this sensor that we have. Where do we connect the sensor? I will show you a picture of the connections. This is our connections, and you can see that the all of the row is positive and in the middle, and the negative on the outside, and the S signal pins are towards the chip. This is quite common. The reason is that all of these S signals need to have, under the board, they have a connection wire going straight across to the chip. We're connecting today to IO33, so we're using these 3 pins, S, positive, negative. The S on your, you can see the little S needs to go on this end. I will show you a picture of the connection. So like this. Okay, you see the picture, so plug it into the board, into IO33, connection 33. Make sure the S is towards the chip. Plugged in. We're going to go back to the runlinc and we will test your connection. We will test your connection. So back to the runlinc. Now on D33, where we have the connection, select analog in, analog in. This is to measure the voltage. And you'll see the number changing. So we have analog in, and here on the web page, you can see the number going up and down. If I put it here in front of the projector, the number will become very low. You see? If I cover my hands here like this and put it closer, the number goes up. So test your controller, put your hand on, the number will go up, and take it away and go down. What is this number? This is a digital number from the voltage reading directly from here. This is the raw number that is measured on the analog voltage. Analog means just any continual voltage. What does the word digital mean? Digital. Have you heard of the word digital before? What does it mean? Does it mean just like some sort of technology? Sorry? 0 and 1, okay? Yes, literally what you're actually correct, but literally the word digit, what does the word digit mean? Digit. Have you heard of the word digit in English? Sorry? Number. A digit is a number, yeah. So when it says digital, it literally means made of numbers. So this technology is made of numbers because the controllers, the microcontrollers, the computers all need numbers. Everything works on numbers. Okay, as we heard, someone said 1s and 0s, so these are the numbers that it uses, the numbers on and off. So it creates analog to digital. So we have a number here, digital number. So yes, your digital televisions, your digital cameras, everything works on numbers because they all have the microchips computers inside. This sensor is a light sensor, but we could be using a temperature sensor. We could be measuring a soil moisture sensor. It also has voltages going up and down, pH sensor, turbidity sensor, even a pressure sensor, okay? Alex actually is also using a pressure sensor on his system. Put in the word sensor into here, and we will then measure the sensor in our code, and we'll react to the sensor. So what are we going to do with the sensor? let's say we have a robber. A robber comes and is detected by the sensor, okay, and it covers the sensor. You can see the number will go up, maybe above 80, okay, above 80. Then we want the code to automatically turn on the lights. Okay, at the moment we have the blue LED flashing. We want to turn on the blue LED, scare away the robber, and when we uncover, then we want to turn off the LED to save energy as well, to save energy. So this is our plan. So how do we do this? Go back to the code.
You also have microphone here, right?
Yeah.
Also microphone here too, right? Yes. Have it to for it.
Okay.
It's okay.
Shortly. All right. Okay, so what we want to do is change this one where we turn it on. Only when we cover the sensor we want to turn it on. Afterwards we can turn it off, that's okay. But when we cover the sensor we want to turn it on. So push this one down and we're going to create some logic. So if we measure the sensor and it's greater than 80, then we turn on the blue LED. Let's separate that instruction. And above the turn on blue LED, we're going to put in the instruction if, and then round brackets. Some difficulty with my keys. Let me go back. This shift, okay. Round brackets like this. I'll make this bigger on the screen for you. Again, it's using the zoom on the browser. Everyone can see right in the back of the room. Makes it really easy. Okay, if, lowercase if, round brackets. And then what we'll do is we will use the analog in and select the device, which is now the sensor. Put the cursor here and click add macro, and we are measuring the sensor. What is the logic? We want to remember when we measure the sensor greater than 80. So simply type in the greater than symbol, mathematics greater than, and the number 80, and then put it in the brackets. So the if means if this is true. If this is true, analog in sensor greater than 80. If this is true, if, then do the next instruction, turn on the blue LED. Okay, otherwise it will not turn on the blue LED. We will wait for 1 second and turn off, but we can do that anyway. We don't need the off delay. We don't need it to flash. So we'll delete the last instruction. And then again, we only have 4 instructions. Turn it on and then wait for a second and turn it off. But only turn it on if it is greater than 80. At the moment, my controller is still flashing though. So how do we activate the new code? Click the stop code, and then click run code to activate the new code. Click run code. And when you click run code, you will see nothing is happening because it is the sensor is not greater than 80. Let me go down to the sensor number. You'll make this smaller. Okay, down to the sensor number. And smaller again. No, okay. Okay, sensor number is 2635. If I cover the sensor, everyone watching, cover the sensor now, it goes above 80. Do you see a blue LED? Okay, and if we uncover the sensor, then after 1 second it'll turn off. Is that working for everyone? Very good. Seems like maybe I need to go a little bit faster. So what I'm going to do before I continue is our next step is to show you how the running can create a web page. You can include your own buttons. Okay, so you can have your own buttons on a web page which can turn on and off, and you can even include on that web page, you can include camera vision. Camera vision only takes one line of code. 2 buttons only take 2 lines of code. Okay, we can even include voice, AI voice, and the AI voice only takes 3 lines of code, the artificial intelligence. So we will add this. But what I want to do first is show you how the runlink can connect to a drone. The runlink is a Wi-Fi device. It is wireless. So it means that if we want to stream, for example, the camera from your phone, if we connect it to the same runlink network, then this can be an IP camera. You can have the settings to share, and this can share on the runlink and then put it onto the web page. 1 line of code. It only takes 1 line of code. I have on this drone a camera on the front, so it will actually share the web onto the runlink web page as an example. I have a sensor here to measure also the height here as well. I would have to be very careful how I run this drone though, because on this screen floor, I believe this drone will be lost because it uses a camera and it looks down its own position. So if something is moving, it means that it needs to stabilize. But if there's no pattern, then sometimes it can be lost. If I put it here on the corner, then it should be able to see the corner of the table and be stable above the corner. Okay, so I'll connect this to the Wi-Fi and then I'll show you the code on how we can connect to the drone. So let me get a battery for that. Okay, what I'll do next is I'll get some code. Yeah, you could like. So Alex has suggested that maybe if we put some black tape on the ground, the drone has some sort of element. If we actually just put some tape across there, that would be enough for the camera to be able to stabilize on the AI. Yeah. Slow S or it is uppercase? Yes. S for sensor. That's uppercase. Is that uppercase for sensor? Capital S or is it small? I think it's a small S. It is capital. It is actually hard to see. It's going to be small. Maybe you can zoom straight to the corner of the dots. Yeah. Okay. Thank you. I can see better. You can see better too. Okay, good. Let's run the status. Okay. Okay, blue. That's good. I believe we have a brackets. Yeah. Okay, go to the top, press stop code again. One code, take it down. What happens? Sensor goes up. Brings it an 80. Activates. Maybe some sort of energy. Because there
usually it goes to the
Oh, that's true. The weight should be above the turn on. You're right. I think that's the problem. Yeah. Because then you will not see it turn on. You don't have a 1 second delay. It will just turn on straight away. So this faster weight should be in here. It's in the wrong order. Wrong order. Create a bigger gap and then copy this to put that above. Now we need to stop the run code. Okay, we found it. See now? 1 second. Okay, we're going to continue. I'm just going to get the drone, the code for the drone. We can use the save and load. So I've saved some code for the drone. I'm going to load some code for the drone in this case. Sure the battery is in properly. A few lines on the ground. Okay, should be okay. All right, I'm going to turn on this drone, connect it to the Wi-Fi, and then you can take a look at how the runlinc can also control the drone. I've loaded it onto the same chip that I have here as well. So let's first of all discuss the drone. We're going to have buttons on here as well. We can see the height, we can see a height graph, we can see the video, but the buttons we can make the drone take off, make it turn. But this is not just so that we can get a remote control for the drone. We want the runlinc to do automatically to go up. So for example, if we have a robber come, covers a sensor, we want the drone to go up, okay? And maybe an AI voice say, intruder detected, sending security drone, make it go up, make it go around, take a video to send to the police. Okay, make it automatic. So let's check the drone first and check the buttons. I'm going to turn it on. I'll put it here. Let's put it away off the screen. Turn it on. Okay. We'll connect to the drone. I believe that my Google Meet may drop out. If that's the case, then we'll have to reconnect after the drone because it takes over the Wi-Fi. So it may drop out for those on the Google Meet. Hopefully it doesn't, but we'll see what happens. I'm going to connect to the drone now. It's turned on. Need to connect. Okay. HTML box. HTML means hypertext markup language. So this is the just normal text, but using the hypertext in the triangles, we can make the browser do various things with our text. In this case, it will make it large. Okay, make it a heading and make it large. Put in your name here. Once this is complete, then you can click stop code and run code. Shall I continue? Do we have that? This is simply text and we're making it a heading. Okay, we're going to test it. Click stop code, click run code, scroll down under all of the port numbers, and you should see your heading.
You're in. Zero.
Okay, very good. Okay, thank you, Peng. We're reconnected again. Actually, Peng, if you're there, did you want to say a few words? Are you able to, or later?
Give me about 5 minutes.
Okay, no worries. That's okay. All right. So Peng is our CEO in Australia, and at the moment he's been letting us into the Google Meet. Okay. Go back to the runlinc. You see Miro alarm control web page. We'll go back to the HTML. Now we're going to one line of code to create a button, but when we click the button on the web page, we actually want red LED to turn on. So let's connect our red LED first. You may have seen the red LED on the picture. Let me share this to the Google Meet as well. Okay, so that's my runlinc page. Let's go back to the picture of connecting the red LED. And this is what the red LED looks like. It is a green and red LED. Actually, this LED can do green and red. And in fact, the negative pin here is correct, but we're going to change this document because this is actually the red LED and this is the green LED. There are actually two LED pins inside. So we connect this differently so that we can have two controls. We can control the green and the red separately as well. So this is how we connect. We go down. We're going to use IO5, 18, and 19 in the signal section, the S signal. Okay, not sure why we're getting feedback. We'll see. So the S signal pins, and so this is how we connect. Okay, this is how we connect this way, because this is the signal row, and we have pins 5, 18, and 19. The S is actually towards the 5. So we're going to use the 19 as negative and then the green and the red LED connections. So this way is different. Actually, if we use this way, we can also connect more than 3 pins. We can have a 4-pin, 5-pin device as well. So connect that in, plug it in. I'm going to plug it into mine. Plug it in carefully, 5, 18, and 19. In the row which is closest to the chip, let me show you another picture. We're plugging it into 5, 18, and 19. So 5, 18, and 19 across here, not the middle row, not the end row. Like this. Okay, Okay, we'll test this also. Go back to the runlinc. Everyone has their green, red LED plugged in. Go back to the runlinc. And then we make D5 digital out. This is actually our red LED, red. And D18 is digital out, our green LED, D18. Digital out, green. And D19 is our negative. So digital out, no label needed because off is actually negative. Okay, on, off. Digital computers use 2 digits. They actually use a 1 and a 0, and the 0 is actually off, and the 1 is the on, and there's also power. So this is how the electronics works. It's faster if it just turns on and off. Okay, so this is actually the negative. We have green and red. We can test this. Now, click the status button next to red, and you should see the red LED. Like mine, you see the red LED. Then turn it off. Go down, click the green LED. You should see green. You see green. Okay, the green LED. Okay. And what happens if we have both the LEDs on? What color will we see? Any ideas? Okay, science. STEM is science, technology, engineering, math, science. Okay, I'm going to give a prize. A prize if you can answer this science question. I have a green LED, I have a red LED. If I mix the lights of green lights with red lights, what color will the light actually be if I mix those 2 light colors? Yes? Brown. This is for paint. It's correct. But light is actually different. Light is different. Yes. Correct. Yellow. Turn them both on and we can see. If I turn on the red now, do you see yellow? It's actually the green and the red. Okay, so yellow is correct. That means that you're going to get a prize. Let me see what I can get. I have hit the koala in my bag all the way from Australia. Thank you very much. What's your name? Judah. Yeah. Okay. Thank you. All right. Very good. Later, I'll give a prize for the AI voice as well. So when we do the AI voice. All right. We have a bright yellow LED. Let's turn off the green. We will have red. What we want to do is create 2 buttons for the red LED for the alarm. Oh, okay. All right. Better? It should be on the tab here now. Okay. All right. Go back to the HTML. We're going to add 2 buttons. Okay, we simply put in the triangle and we use the HTML hypertext button, the word button, lowercase, a space. When we click this button, we want it to turn on from the web page. We want it to turn on the red LED, and the top of the button will have alarm on. Okay, button on click equals. So when we click the button, in the quotation, we will turn on the red LED. You see the red. We have D5 digital out red. We'll put in the word turn on. Be careful of the upper and lower case. This is actually a large O, and the other letters are small. Make sure you put in the quotation mark. I can zoom this in even more. Okay, turn on, and then we can use the word red for our red LED. And then end the quotation mark and the triangle brackets. So the button, when we click the button, will turn on the red LED. On the top, we want a text label, so we'll simply type in alarm on so that it is on the top of the button. Okay, then we slash end of button, like that. One line of code for one active button. When we click the button, we want it to do this command and turn on the red LED. It's an alarm button. Okay, we also need an off button as well. Everything okay?
Yeah, that monitor is live. You can have a look and check.
Oh, okay. All right, thanks. Okay, alarm on. So when I select the button, then we're going to copy the button. So we'll make an off button, but select the whole line. It's button copy. Go to the next line. Click paste. And we'll turn off the red button. Alarm off. Okay, so the second button, we have changed the on to an off and alarm off. Okay. All right. So go to the stop code, click run code, go to the bottom of your page, and you should see your heading. And also the alarm on, alarm off. When we click the alarm on, the LED turns on. If we click the alarm off, the LED turns off. Okay. So time. I'm going to do something unusual. I don't usually do this in the other workshops, but you seem to be very quick. So I'm going to ask you a question on this coding. Instead of the red LED turning, okay, red LED turning on, we want the red LED. Okay, alarm on, red LED. When I click the alarm off, what if I want the red LED to turn off, but I want the green LED to turn on instead when the alarm is off? Any ideas how we could do this? Sorry? If else, yeah, we could put if else, we could put in a function, etc. Any easier way, maybe? Question is that when I click the alarm on button, I want the red LED to turn on. But when I click the alarm off button, I want the green LED to turn on. So it's not red anymore, it's green. Click it again, then it's red. It's a bit of a trick question because actually, if you think about it, you click it, it goes red. You click it again, you want it to go green, you actually need to do two operations. What do you need to do? If this is already red, what do you need to do? Need to turn off the red, yes, and then turn on the green. So that's the two things. Okay, so you turn off the red and turn on the green. So we already have a turn off red, we need to turn on the green afterwards. But if we then switch from the green to the red, we also need two operations. What's that then? Goes from green to red. Turn off the green and turn on the red. Okay, very good. Okay. In fact, there is actually, you can put in two operations inside the button. So let's do that quickly. It's actually quite easy. when you see how, go to the button. We're already turning on the red, but maybe if the green is already on, we need to turn off the green. So this is how we do it. Put in a quotation mark. Type in the turn off green. Like that. So in case it was green before, we will turn off the green, turn on the red. And make sure the spelling is correct. We have green. And on the other one, we turn off the red and turn on the green. So we can copy this one, make it turn on green. Yes, we can have one button and have two operations. So this one would now be turn on green. Okay. So we click the first one, alarm on, turn on the red, off the green. Otherwise, alarm off, we'll turn off the red and on the green. So if you click stop code and run code, test. Click the alarm on, red. Click the alarm off, green. Okay, makes sense. Red, green. Okay, now I actually want you to add one more instruction. You're not just the on-off green. We're going to turn on/off a buzzer. You have a buzzer. Okay, we're going to add, when we turn on the alarm, we want the buzzer to turn on also. And we turn it off, then we want the buzzer to turn off also. Keep the red and the green, but we can also put in a buzzer. Where do we connect the buzzer? We're going to connect it to D23. D23. I'm going to make this an exercise for you. So I hope you can finish this before I show it on the board. So D23 is the buzzer, the S is the signal. You should be able to connect that now because I have given you enough information. But anyhow, I will help you a little bit with the picture. So I'm going back to the documents. And we're going to connect to IO23. So the signal is here on the end connector, 23, S for signal, plus or positive, minus. We need to connect this in, plug it in. If you have a sticker on your buzzer, it says, my buzzer says remove after washing. Maybe you don't have a sticker, it's already off. But the washing is a chemical wash. So sometimes these are soldered and chemically needs cleaning. It protects the buzzer inside. Do you think the sticker will block the sound? Everyone says no. But actually, the air is like water. If we throw a ripple, you throw a rock, it creates a ripple, and then here actually picks up the ripple of the sound. Okay? If you block the ripple in the pond, then the waves will not go the edge. So this can block most of the ripple in the pond. You might hear a little bit, your ears are quite sensitive, but maybe it will block it completely. So you may need to unpeel that to hear the buzzer. Plug it in, test your buzzer, and then add the code over here. So it says turn on, turn off buzzer, D23 buzzer. Okay. I'll come back and I hope that it's working for your alarm on, alarm off, because I need to go to the washroom for a minute. Okay. What's the one? What's the alarm on, alarm off buttons on your web page, not just the test.
You have taken care of the signal, yes, yes, positive, negative. And for the board, normally the row is close to the board. But for some sectors, very sensitive, if you swap it, and then also broken. Especially LED, maybe some LED. Yeah, you see this one actually. Remember, it's very easy. Okay, this is the board, and then the row that is close to the board is signal. Okay, it is signal, and then in the middle is a positive. Okay, and then outside the boundary here is like a negative or the ground. Okay.
Yeah, these ones are contract ones.
Oh, you missed that one.
Because of about the we have to check the screen, huh? Because it's somehow wrong. Maybe there are something. What did you want to have it on?
Okay. Okay, how do we go? Anybody has it working? Yes? Okay. Let me see. I'm in your web page. Click the on or off. Let's scroll down. Go down to your web page. Just go down one. Ah, you created extra buttons for buzzer on, buzzer off. What I want is the same button. The same button when you click this button, the alarm on button. I want it to turn on the red LED, not the green, but I also want it to turn on the buzzer also. Yes, you can put in the third command into this line. Turn on red LED, turn on green LED, turn on buzzer. Need to call it buzzer, put in the name and turn on buzzer. When you click the alarm off, then this is correct. Then add turn off buzzer. Turn off buzzer. Okay? Like this. Okay, so turn on, similar to this one. Turn on buzzer. Okay, quotation mark is wrong, so let me make sure I have the quotation mark in the right place. Thank you, Dr. Sompon. Correct. Make sure that the quotation mark is at the end here. And the second one, we need to turn off buzzer. Copy the turn on, put it here, off. Okay. If we have more instructions, how, this is only a small box, we can actually go to the corner here and we can pull it down and up, okay? We can actually pull the box bigger if you need more instructions in the box. So working now. The buzzer needs to be on D23. So go down to D23. It should be digital out buzzer. Correct spelling, uppercase. And the plug it should be plugged into D23. The S is towards the chip. So when we click the run code, alarm on, we'll turn on stop code, run code. Okay, alarm on, alarm off. Okay, but is this really scary for a robber? If actually a robber comes, they see red light, green light, maybe they are detected. They don't want to be detected, but it is a buzzer. So maybe if the buzzer was louder, then maybe that would be better. So if I took off the sticker, do you think it would be much louder? Let me try. Yeah, much louder. Okay. Good. But what would be even more amazing is if they're detected and there's a big voice that says, intruder detected. Okay, intruder detected. Run or go to jail. The police are on the way. That would be even better. So we're going to create an AI voice. But before we do that step, the next step, I'm going to ask Alex to actually present his invention, which includes, first time in the world, actual satellites as well. So I'll maybe ask Dr. Sompon to maybe take a video of this as well, because we're also going to see if we can include this in, especially since this is in University of Wollongong, Australian University, then we can help to make this part of a short video which we're going to present to the Premier on June the 12th as well. Okay, so we'll ask so Alex, you have a screen to show?
I have a screen and this one.
Okay. All right. Okay. Yeah. So if you come close, and we'll take a separate video of that as well. This presentation, and you can show the screen and everything as well. Okay. Since there's only a few of us, if you can't see this clearly, I'm happy for you to stand up and gather, even come around a little bit closer to his presentation as well. He can show what he is doing. You can see his system over there as well. Okay, yeah, come around. He's actually brought this all the way from Australia. Alex, just include an introduction of yourself as well.
Yeah.
And also the purpose. Okay, and Alex has brought Royal Adelaide Show. Adelaide is South Australia, that's our city. And the Royal Adelaide Show is sponsoring this trip, actually paying for his flight, for his plane, to come all the way across to Malaysia to come in the international competition at ITEX. So we're going to make sure that we have our Royal Adelaide Show cap on as well, so we can show the Royal Adelaide Show. We can take some pictures as well. Okay, if you put your cap on, then we can include that as well, Alex. Yeah, thanks. And maybe we can even take a couple of pictures afterwards for the show as well with the caps. Be nice. They print a magazine. They actually have a society magazine, the Royal Adelaide Show Society. It's very, very big. 500,000 people go through the Royal Adelaide Show in 9 days. It's very big, like Disneyland. There's so many different parts and sections in there. I have had comments from other people overseas and how big the Royal Show is. Okay, adjusted. Looks good. Okay.
Okay. So, hi everyone. My name is Alex. I'm from Adelaide, and I study at Flinders University, studying electrical and electronic engineering. I've been very passionate about STEM for a long time, since I was very young. I joined STEM Cell when I was just 11 years old. I've been coding ever since, and most recently on the runlinc platform, and even on the Marietta satellites. Alright, so the purpose of this world first Marietta satellite is to transform STEM education, to start teaching people on how they can include the satellites in their own projects, while Marietta brings the satellites into the industry, so we can have engineers who can actually program the satellites, program their own devices to transmit to satellites from the remote locations. So I'm bringing the capabilities of this system into schools and universities. And we have done the surveys in many places, and so far there's been no students that heard of the system being used in projects. And with the runlinc, we can save a lot of time. So this system can be programmed in hours instead of months. So for a satellite system, the back end can be extremely complicated, but with runlinc, it's simplified. So it's only in a few lines of code you can get data to the satellite. And also saving money for stakeholders. Instead of spending millions of dollars on research and R&D, with this system, it's very easy to develop. Right, so this is my project. This is the smart irrigation system with satellite runlinc Marietta satellite IoT and smart leak detection. And this system helps to save both money and water, to save the businesses and the planet. It'll reduce the cost for the businesses because they're using less water because of optimized irrigation. And they're also saving the planet because we can save water. We can send the water that isn't used in irrigation to countries that don't have water. We'll bring our laptop. They actually have a very special infographic that shows just how much water is being wasted. So why should we conserve water? Well, in the world, we only have 3% of the fresh water on Earth. 3% of the water on Earth is fresh water, and of that 3% of fresh water, only 1% is available for human consumption. That's only 0.03% of all water on Earth is available for humans. So this graph here is the distribution of fresh water in the different industries. And so 70% of the water, on the fresh water that's available for human use, is used in agriculture. It's a huge amount. It's about I think 2 trillion cubic meters of water, and then 20% is in the industrial sector, and only 10% is used in household uses. And out of that agriculture, so overall, 28% of all the fresh water is wasted because of agriculture, and that is 1.2 trillion cubic meters of water. So that's a huge amount. So if you made a cube of that water, that would, one side of that cube would span the length from almost from Adelaide to Sydney. Just one side of that cube. And that's also equivalent to 14 Olympic swimming pools every second of the year. So for every second that we're counting, we're using we're wasting 14 Olympic swimming pools of fresh water. Okay, so 1 in 4 people in the world don't actually have access to fresh water, which is really quite confronting. That every fourth person in the world doesn't have access to safe drinking water. So if we took just half of the water that's being wasted from the agriculture and gave it to these people that don't have fresh water, we can pretty easily solve this problem. So that's what the aim of this system is. Okay, so onto the technical details of the system. So
Can you hear me?
this is my web page that this is directly connected to the chip over the runlinc network. So this is an isolated system, this computer and this chip. And it has some basic controls to set how long you want it for,
Can you hear me?
swap between water. And it also
Yeah,
has,
we can hear you, Peng.
it also has the
when you're ready.
state of the transmitter.
We're just getting Alex to present first.
And this system can actually use the pressure sensor to detect if there's a leak. So if there's a leak in a pipe, the pressure is going to drop. And the pressure sensor is accurate enough that it can detect every little pressure change in the pipe. So currently the pressure is 0 because there's no water. All right. And it also has moisture sensors, so it can detect how much moisture is in the soil and automatically adjust how long it waters for. So you can optimize how much water you use, and so you don't overwater your crops and waste too much water. Okay, so I can actually do a live demonstration of the satellite transmitter. So what I have here is a satellite simulator. So this little device acting like a satellite. So I'm going to transmit a satellite signal from this device to the simulator. So then I press send now. It's going to ask the satellite transceiver the time. It's going to ask where it is. And it's going to send all of the sensor data in a small 40-character string. This is all of the sensor data, and it also includes the GPS location and the time. So you should see a little green light start flashing. Okay, so this is the Mariota Irrigation Monitoring Portal. So this website can be accessed anywhere in the world, and it's able to, so you can receive your data from from anywhere in the world, and this can be placed in a remote location with no internet connectivity, with no cellular. It doesn't need any sort of connection. It transmits directly to the satellite. So this can be used in the middle of Australia. It can be used in the middle of Texas in the USA. It can be used even in the middle of the ocean. We're transmitting data from ocean monitoring buoys. So I press the get data button. It updates the data. I think the last data was 12:06. So that was a few minutes ago. That's the data that I just transmitted. So it's now made its way from this transmitter to the satellite and to the Mariota network. And then finally, into this web page where it's made a graph of all the data as well as the location, so you can see where it is. Okay.
Just a question, Alex. If you used another system, I believe that you have tried in the past to try using other systems such as Arduino, C++.
Yeah, I'm using.
What difference do you think that would make to the amount of code and time?
Yeah, if you tried to code the system using Arduino and C++, it would probably take months, maybe even years, to program a satellite system like this. With runlinc and Mariota, it's very simple. It's very simple coding. You can do a very basic data program in maybe 20 lines of code.
Okay, thank you very much. Sorry, yeah. Alex, go on.
Yeah. So the pipes that we're using here are just basic pipes, but they can also be also use the Nova Fast pipes, which are composite pipes. They can carry oil, they can carry water, and other chemicals. And these pipes are composites, so they last over 50 years. And we can also measure the strain in the pipes to see how much pressure is in the pipe, how much strain they're under. And we can transmit that data over the Mariota satellites from remote locations. So that can be really useful for pipes that transmit, for pipes that carry water, chemicals over long distances. And you might have a spot in the pipe that doesn't have, you want to put a sensor on a pipe in the middle of nowhere, and there's no other way to get the sensor data to a server. So you can use the satellite to receive the sensor data.
Okay, and it's a strain graph. So in fact, we can use a little strain sensor, which is very accurate as well. Can be used on the runlinc, so it can measure the strain on the pipe. In fact, this picture, I was there. This is actually inside a steel container. They were doing the testing up to 10,000 kilopascals of pressure, and then it actually created a leak. I said to them, we're just testing the runlinc, and they said, no, we want to do a destructive test today, so we're going to actually measure until the pipe, something happens in the pipe. That's why we put in a metal container for safety, and you have to step outside. But because this is Wi-Fi technology, I could still get data even outside the protected box on that day. And we could measure the strain gauge changing as well. And this data will be sent to the satellite in the remote regions. So that is the strain gauge on the Nova Fast pipes. It's a multi-million-dollar company. They use the pipes for petroleum. They use the pipes for acids, for big industry, long pipelines. They even use it in the submarines or under the hospital for reliability. They need to have at least 50-year warranty. This is not just plastic, it is composite, like a carbon fiber composite pipe. So it's very, very strong and reliable, and it needs to be for that as well. Give Alex a big hand, give him a big clap. Okay, excellent. Thank you very much, Alex. Thank you. And I just have to say that when we went to the Royal Adelaide show, I was with the judges, and one of the, he had water running through this. One of the pipes actually came off from movement, and a little bit of water came out, and then it stopped. And I looked, and there was a voice saying leak detected, okay, on there, AI voice. And this was accidental, but it showed that the solenoids closed to stop the leak. Like within a couple of seconds, it just stopped, and there was an AI voice there already. So yeah, very impressive for the judges. Okay, yeah, within 1 second, it can actually stop the leak very quickly. And also, your pressure sensor, I believe, can also, if it has a blockage, can also detect the blockages.
Detect blockages. If it detects a raise in pressure,
yeah,
then it detects something blocking the pipe.
Yeah, everything on the runlinc. Thank you very much. Okay, thank you, Alex. We hope that we get gold and a trophy. We'll see at the Royal Adelaide show.
Like even if the solenoid's fail, it detects that.
Sorry?
Even if the solenoid's fail and close, it detects that.
Okay, failure of the solenoids. Okay, failures in the equipment. Very good. Okay, Peng, are you still there? Peng, are you still available? We'll just see if Peng is available to speak for a couple of minutes.
I need another 5 minutes.
Okay, all right. That's okay. We'll continue with a little bit of coding, and when you're ready, please let us know. Thank you. Thank you, Peng. Peng is our CEO in Australia. Okay, what we're going to do is we're going to make it so that when we click the alarm on, we want voice to come, an AI voice. Okay, so how, I'll click the stop code on this one. What we need to do is add, instead of the buzzer, we want to add more code, but this will become very messy if we try to insert it into the button. So what we'll do is we'll actually use JavaScript to create a function. The function, we can have the code, and then just one word can do the whole function. Okay, so I'm going to show you an example of the function. What I will do is I'll go to runlinc.com, and this is actually free. And you can, even without, even if you do not have a controller, by the way, we are selling these controllers today. If you want to buy some after they're 120 ringgit for the desktop you have, the parts, the cable, everything if you wish. But also we have some free online projects too. So if we go to runlinc.com, then go to online runlinc project. Okay, then we have these 7 projects here. One of the projects is the information voice buttons. So if we click that one, we have some example code here, which is a function for an alert voice. Alert voice. I'm going to copy that and put it into the JavaScript. Okay, this is a function that you'll need. So you'll need to, when you actually add the alert voice and activate it, then it will take the text, intruder alert, or any edited text that you change, and it will change it to speech, and then it will take the speech and put it into your browser so that your sound system will speak the speech. So just these 2 lines of code, but you need the function. So if you have internet access, okay, then you can go to runlinc.com and get the JavaScript. Otherwise, you can also type this in very carefully, upper and lowercase. Uppercase is the A, uppercase is the V, uppercase S. S here is uppercase, the U here is uppercase. The S here is uppercase. It needs to be correct uppercase, lowercase. We want you to put in the function. We can create the voice. I think there's noises across the university because when I went out in the hall just now, I also heard it. So I don't think it's just here. Okay, once we have this, once this is correct, then you can also change, instead of the buzzer here, then we can use the alert voice. So the alert voice, we copy, we can put it here instead of turn on buzzer. Then copy it again, copy. Going to replace the turn on buzzer to an actual voice, paste, okay? So we have the alert voice, which will do the function. So this is a function we can put between the curly brackets here. We can put many instructions as a function. And we can give it a name on what we want it to do. Okay, once you have this, you can click stop code, run code, but the voice will be from your browser. So you need to make sure that your laptop or your computer actually has sound on and the sound is up. When you click it, you should hear the voice from your computer. When you click the alarm on button. But the voice, everyone is doing really excellent today, especially so those that are doing first-time coding. Okay, you're making good progress, making very good progress.
I'm ready.
Okay, all right. We're going to hear from Pang, our CEO, and I'll stop the sharing so that we can maybe, Pang, you're going to be able to also share your video with us. Okay, this is Pang Chu, our CEO. We can see you, Pang.
Thank you. Hello, everybody.
Okay, you can wave back, and I will give you a vision of the audience here as well. And we have Dr. Rosemary. Wow, just in time. Dr. Rosemary, we have been doing lots of projects here at University of Wollongong in Penang, and Alex has been presenting, and just now we also have Pang, who is going to also present as well. So they've been doing many projects, alarm projects, and Alex has shown his smart, first time in the world watering project with an actual satellite, so you can send the signals to satellite as well. World first. World first.
Thank you very much for letting me in.
Thank you for joining us, Dr. Rosemary. Dr. Rosemary has been doing many things in Thailand as well, and I believe one or two of her students have even visited Dr. Sompon. Is that correct, Dr. Sompon? Yes, okay, very good. Dr. Rosemary, Dr. Sompon is here. Dr.
Hello,
Sompon,
Dr.
wave
Sompon.
your hand.
Wow,
Yeah.
you are there in Penang.
He came back from Thailand to me here in Penang.
How long
Dr.
Yeah.
conference will last?
He will be here until tomorrow in Penang, and today we are flying to KL. Okay. All right. So go ahead, Peng.
I'm just listening because I have a class right now.
Because Dr. Rosemary have a class, do you have 1 minute to maybe say a few words from your school?
Yeah,
Dr. Rose-
this is I'm
Maybe-
currently teaching.
Maybe Dr. Rosemary, tell us your experience on this runlinc in your class.
Oh, the runlinc project is most of the students are excited. At the same time, they are doing projects, and we presented to Kuala Lumpur, Malaysia last year, and they won 3 awards regarding about how to connect 2 lines of code using the runlinc system to control the flood, especially here in Bangkok. And the radiation counter that we did, done by one student who is a Japanese. He is now monitoring how much is the radiation, the amount of the heat temperature in Japan, because they are experiencing this before. Those are the projects that we presented and we won.
Thank you, Dr. Rosemary. Dr. Rosemary has been teaching in ASEAN countries for a long, long time. And she comes from the Philippines. I think Dr. Rosemary taught in Brunei for about 16 years.
Yeah, 16 years in Brunei.
Yeah.
And doing all the science competition. We are hosting and inviting science seminar workshop for all the science teacher students across Asia. I'm still involved with Brunei Association for Science Education, and until now, I'm one of the committee giving them some advices regarding consultancy because I'm stationed now in Thailand, still connected. And I'm also one of the committee working as a judge to all the science competition every year in Malaysia.
Wow. I think that
And
is involving
this is administered by Utah,
Utah
the
That's right.
University of Tunku Abdul Rahman.
in Malaysia. That's right. Yes. Nice. Thank you so much. And I'm sure that Dr. Rosemary will introduce a lot of students to the play and learn stay set up by Dr. Sompon.
Soon.
Yeah. So set up a boot camp
Can you take some pictures?
I
at
will.
Learn House. And already you have Hilton as one of the students who's been to the Play and Learn House just a few weeks ago. So thanks to Dr.
Yes.
Rosemary, the word is
And
spreading.
thanks to Dr. Sampon for helping my students too, especially Hilton.
Absolutely. Thank you for this input from yourself. I know you're in the middle of a class. Thank you.
Thank you. I will just switch off the camera and I'm listening in mute.
Nice. Thank you.
Thank you so much. Nice to
All the
meet you
best.
all.
Thank you. Bye.
Thank you,
So-
Dr. Rosemary.
Yeah. So
Thank you, Dr. Miro.
Yeah.
I'm on, but I will mute and switch off the
Sure.
camera. I'm still listening.
Thank you.
Okay.
You can
Thank you.
see Royal Adelaide's show. Okay.
Yep.
Thank you.
any more projects to go, Miro? Because I need to know how much time I have.
We are doing quite well, so we're happy for you for 5 or 10 minutes. Okay, it'll be okay.
Oh, that's a long talk.
5 minutes is fine.
Yeah. I think I would just start with the relationship between Adelaide, where we come from, Alex, John, Miro, myself, we come from Adelaide, a sister city of Georgetown. I think last year they celebrated, or still celebrating, the 50th anniversary sister city relationship. So Georgetown was planned by Francis Light, the son of William Light, who planned Adelaide City. That is many, many years ago. And then 50 years ago, they formed a relationship between Georgetown and Adelaide called sister city relationship. So we have a sister relationship with Himeji in Japan, with Christchurch in New Zealand, Rajasthan in Jaipur in Rajasthan in India, and another Shandong as well. So sister cities network. So everything that we do with UOW could be transmitted through to these sister cities relationship. So with the hope that today's workshop, I think Miro mentioned about his he and Alex presentation to the Chief Minister of South Australia, as well as the Federal Science Minister, together with the head of Australian Space Agency on the 12th of June. And I'm confident the South Australian government launching of the SAT, this is a pre-launch sort of get together. It's all fully tested. They're planning to launch it in July this year through Elon Musk, I think SpaceX, somewhere in California. And so if possible, these satellites being the point of contact for exchange of education between South Australia and Penang. So between the two chief ministers, I hope this will become one of the events for this sister city relationship celebration. So what is to be celebrated though? What is the standout? What is the takeaway message between the chief ministers? What is the impact, the economic and social impact on this workshop that you are doing at the moment? So to sum it up, from the survey that I think Miro himself done in so many countries, just a couple of weeks ago in less than that, in Nepal, he was in 111 University. And then he got a show of hand there that students there are very keen to use satellite internet of things for their engineering project, which they do not have the technology or the means to do that at the moment. So that is, again, repeated with University of Kuala Lumpur. Again, these professors there wants it not only for their own students at university level, they would also like to, I think, introduce it to about 50 science schools. They call it Mara Science Schools, spread throughout Malaysia. And I think Miro is going to one of them called Mara Science School Bentong. I think before the ITEX, isn't it, Miro? So this then again confirmed that they call it world first for that reason. That is the first time ever they would have the opportunity to basically open up a different frontiers in STEM education. You can imagine the amount of application, right? A bridge in the very remote area in Ohio, for instance, in America, that have no satellite or no, what do you call, internet coverage. Then suddenly you can measure the strain on the bridge, whatever other parameters like that you want to put on, in case too many trucks go through that bridge. So you want to measure the rust as well, and take all the data and plot the graphs in the schools, in wherever the transportation control room is. So this would then have a very major implication in terms of application. I think Alex was showing about this pipes project, which is already industry application by Myriota in Texas, a massive farm that you would need helicopter in order to manage the farm. It's so big, hundreds of thousands of cattle. And there again, that is MyRiota IoT satellite application, industry application. Then as far as Alex is concerned, his is MyRiota IoT satellite applications in schools and university. You know, first time ever that we are able to introduce this to schools and universities across the world. I think there's about 12 satellites by this company. So again, what is the impact? Let's look at the economic and social impact. So I think you have got some idea now as to the first benefit is save time. You know, because running easy coding help you to reduce the time in making a STEM engineering project. So that is, for instance, a project that may require about 100 hours can be reduced to 10 hours. So you have to verify that yourself with a few lines of code compared to hundreds of lines of coding to do the IoT Internet of Things project in STEM. Then the time you save, you now can incorporate satellite IoT into your project. And then being the world first, you would have the potential to win STEM engineering competitions, innovation competitions, even entrepreneurship competitions that involve marketing and problem solving, you know, all the soft skills. Don't just go for STEM competition. We've been through that before. And we are always the winner because they do not expect engineers to go into entrepreneurship competitions. They expect all the business schools students. And that was many years ago, not even with this technology. Now this is the world first. For sure, you'll be able to win those competitions. Then get on to applying for scholarship. UOW is one of the top universities, and they are expanding very, very fast. So you, after your bachelor in Penang, hopefully you can come to do postgraduate in Australia, UOW. And then these, what do you call, these, so save for time, end up with adding something that is extremely new, and then winning STEM and scholarship competitions. So then who are the stakeholders that can benefit from your experience? The parents are the stakeholders that fund STEM projects, you know, pay their kids to go to coding clubs and so forth, right? STEM clubs. Coding clubs are part of STEM. And I heard that in Malaysia, average the coding, one parent sent the Miro, I think from Penang, isn't it? Iqbal, from Butterworth. I think he's paid about 17,000 ringgit for his son, 11 years old, to learn coding over a certain year periods, you see. So again, it saves them money if you can reduce the time. So from parents to schools to universities, all funding the STEM education. And now STEM satellite IoT. Yeah. And if you compare that, 100 hours is not even accurate because they've never been done in schools before. So it's beyond 100 hours. And you will be able to achieve the same thing like what Alex did is in less than that 100 hours, more like 10, 15 hours. Then you have the United Nations, the governments, all funding by the hundreds of millions of dollars. So this is the economic part of the story that will help you to win competitions if you do research on here. And then you have the big tech, and the big techs are the Googles, the Microsoft, and then the big four financial company, even charities that fund STEM education, let alone United Nations, you know, by the hundreds of millions of dollars worldwide. So you have a purpose from today's workshop. I think what I like about Alex's story is he's helping even the pipe business to grow their business by students in Malaysia, in Nepal, in Thailand, looking for businesses that require pipes, like water service businesses. like petroleum businesses and like wastewater management, chemical businesses. They all need pipes. So students can look for internship with these companies and offer them a different type of pipes. You know, Nova Fast Pipes, who is a major partner of ours in South Australia, because Miro was able to put a strain gauge onto their pipes that change the adding value to the pipes. So I think this company, together with my Ryota, will be joining Miro in the presentation to these VIPs, you know, the chief minister and the science ministers on the 12th of June. So again, make a case study for Miro to present, so that if he's successful with the chief minister, hopefully the chief minister will call on your chief minister in Penang, then UOW students should be part of the presentation. So that is another avenue for you to create a network in order to increase your employability. So my role is to show you how a technology, a game-changing technology, will be able to help to develop your future career. You know, and I think that is an important aspect. Thanks to Dr. Yip, Dr. Yap brought this satellite company is extremely keen to support UOW in order to get the students the best STEM engineering education in Malaysia, obviously in Australia too, because the main office is in Australia. So any questions for those who are attending, please? Any questions at all, so that we can spark more ideas? And I'll take this opportunity to thank Dr. Sompon as well for his dedication. Almost every online webinar that we have over the last few years, when he has time, he's always there to share experience. But when Dr. Sompon shares experience, Dr. Sompon is also learning. We are learning from him too. And throughout this period, I think it's pre-COVID that we got together. And now he has built a house that is fully fitted with IoT. And now he has the satellite IoT transceiver is going to now reach out globally to any countries at all, especially those that need help in Nepal, Bhutan, India, you know, even America. There's a lot of students there who are underserved, you know. And I'm not sure whether Latoya is still there. Latoya is actually from Philadelphia. I think it's pretty late there now. She will be about 1 a.m. in the morning. Again, Dr. Sompon will be connecting to them using his skills in so many years of teaching and passion about helping students who are disadvantaged, you know, the underserved, they call it, students, in order to give them a fair chance. I think this will give them a fair chance because he's number one, right, in the world. So if Dr. Sompon put them in front of him rather than reach out directly to those who have computers, who have all the facilities that they have, then these poor kids, poor students would have a chance in life, and then build up the network globally. And obviously, this is beyond, as you would imagine, just a STEM in class, you know. Yesterday, I think in IEM, Dr. Miro asked for help to identify where is the best place to have Hakka noodles, you know, Hakka food. And this lady in IEM gave him a link, and he told the lady in IEM that he will be introducing Hakka technology to these restaurants. So you can do that too after Miro has left Penang.
Yeah.
Look at the house there. The Sompon is.
Thanks, Peng. Yeah, we'll get Sompon to show his house, but I wanted you also, since our Dr. Yip has come, maybe you can also say hello to Dr. Yip, who is here as well.
Oh, Dr. Yap, sorry, quite a while we have not spoken because we are so busy here, and yourself there too. So thank you again for the opportunity. to set this up, and I'm sure Dr. Sompon, Dr. Rosemary from Thailand, both from Thailand. Rosemary is online, and then with all these friends like Alex, John Farmer, and so forth, they all would be experiencing something Australian, but in Malaysia. So thank you, Dr. Yap.
And thank you, Peng. Everybody, please give a clap to our CEO, Peng Chu,
Thank you.
all the way from Australia. Thank you very much.
I'm like watching a movie here. What Dr. Sompon is showing here with his play and learn house. I saw earlier there's a structure there. He captured everything from grounds up. So this is going to be a major STEM satellite IoT center of excellence. Thank you, Dr. Sompon. Please go ahead.
Okay, we'll get Dr. Sompon to describe a little bit about his learn house. You see, this is his drone that he's been able to put. Dr. Sompon, do you have a microphone where you are? I don't know if he has a mic, that's all. It looks on the Google Meet like he's back at home, but he's using a virtual background.
Dr. Sompon, you're muted. Yep.
Sorry, Peng. It's causing feedback. So.
Okay, no problem. I know the story, so go ahead.
This is amazing.